All right, let's have a look at this question. It says DNA found at the scene of crime can be compared to the DNA of a suspect who may or may not have committed the crime. However, even if the DNA matches, there is still a chance that the DNA came from someone else, someone other than the suspect. The way in which evidence about the chances of such a match is presented can influence a jury's decision. In a study, two groups of people were told that a suspect's DNA was a good match to the DNA sample found at the crime scene. The chances of this match were presented to each group using a different method. Both groups were then asked two questions. The results are shown in the table below. So unlike the older techniques, such as the one considered here, modern DNA profiling techniques can theoretically match DNA with almost 100% certainty. So this is saying that there is a good chance, like there might be a chance that even if the DNA matches the suspect may not have committed the crime. So probably this is talking about by maybe 1970s or 1980s when the DNA technology wasn't that advanced. But this part is saying that it's now pretty much advanced, so it can match. So if the DNA matches 100%, then there is no other chance that this DNA could have come from someone else. Now this is group one. So group one was presented with the percentage method, and group 2 was presented with the frequency method. So what is the percentage method? It says there is a 0.1% chance that the crime scene DNA is not the suspect's. Okay, so this is what they were told. So group 1 was told this. So it was saying there is just a 0.1% chance that the crime scene DNA. So let's imagine there is a suspect. So you have this suspect, and you have this DNA sample. So there's a crime scene. So in a room, let's suppose that there was this DNA sample. And this sample was analyzed. And what this says is that DNA found at the scene of a crime can be compared to DNA of a suspect who may or may not have committed the crime. Says, however, even if the DNA matches, there is still a chance that DNA came from someone other than the suspect. And they were told here that the DNA was a good match to the DNA sample found at the crime scene. So what we can see, so probably scientists have analyzed the sample, and they found that this is a good match to this person's DNA. It's a good match. So these two groups of people were already told that this sample is a good match to this suspect. And what this sentence here is saying is that there is a 0.1% chance that the crime scene DNA is not the suspect. So there is a tiny bit of chance that this DNA isn't actually this person's DNA. And group 2 was told the frequency of people with DNA that matches the crime scene DNA is 1 in 1,000. So yeah, do you guys understand this? So it says the frequency of people with DNA that matches the crime scene DNA is 1 in 1,000. So if you find this sample, you found this sample, and then if you just randomly pick 1,000 people, like one person in every 1,000 people, this sample will match that person's DNA. All right. So if you have another 1,000 people, let's say you have 2,000 people, then another one person in this 1,000 people will have his DNA matching with the sample DNA. Okay. So this person might be an unlucky person. All right. Who might be one. So he may not be the actual the criminal, but his DNA can match with the sample DNA which was found from the crime scene, because he is like one unlucky this unlucky person in 1,000 people. And then there was the two questions were given. So question 1 says, was the crime scene DNA almost certainly the suspect's? When group 1 was presented with this sentence here, 28% said, yes, certainly this guy is the DNA that was found in the sample certainly belongs to this person. 28% said that. Okay. On the other hand, when people were presented with this idea, okay, they said that only 8% said yes. Well, this sample DNA matches, almost certainly matches the suspects. Okay, so why is there a difference? So the problem is that this one here is actually the same as this one. So 0.1% is actually the same idea as 1 in 1,000. Okay, but when people were told this, 28% said that the sample DNA certainly matches this person, and only 8% said this sample DNA matches this person over here. And second question was given to them. It says, how many out of 500,000 people are expected to have DNA that matches the suspects? So, well, over here, 1 in 1,000, unlucky 1 in 1,000, you know, that person matches the sample DNA. So if you have 500,000 people, of those 500,000 people, how many people would have DNA that matches this sample DNA over here? Well, in this case, 74% answered correctly, and that's understandable because this is pretty easy to understand, you know, 1 in 1,000. So how many in 500,000? So I think that's pretty easy to answer. And well, on the other end, when people were given 0.1% rather than 1 in 1,000, even though this is the same idea as this one, only 26% were able to answer this question correctly. Now, the answer for this one is actually one of the questions in this test. So we're going to see the next question. I'm going to see question 6 in the next video.